Okay, so before that, can you hear me? Okay, I record. Alright, okay, so we will continue this chapter. Okay, so the third layout, okay, so the next one is the warehouse or the storage layout, okay. Right, so the objective for this type of layout, okay, so different layout have a different objective, okay. So the objective of this layout is to find the optimum trade-off between the handling cost and cost to associate with house space, okay, because remember warehouse, they have to handle a lot of stock products and different type of product variation. They have very high variation products in the warehouse. Okay, all right. So and also that when we want to find the trade-off means that the management, okay, would like to maximize, okay, the total or maximize the utilization the total cube of the warehouse. Okay, so warehouse they have cube to keep or to store the products. Okay, so they would like to utilize all their cubes. Okay, and also that we like to reduce the handling cost. Okay, and also that to maximize the use of the space in the warehouse. Okay, right. Okay, so the handling cost, okay, so cost that associate with the handling cost is the cost for transaction, okay, incoming transport, storage, moving the material or finding the material, okay, and then outgoing transport when the product come in, so that is incoming transport, okay, and also when um, the product would like to go up, that is the outgoing transport, okay. Cost for equipment, cost for people, material, you have to pay your workers for supervision to all the works, and also you have to insure your workers because every house there is high risk, okay, and also the depreciation cost, okay, and okay, in the meantime also, okay, and also that we said that efficient or effective warehouse layout, okay, can minimize the damage and the spoilage of the material in the warehouse, okay. So we want to reduce the damage and spoilage in the warehouse, okay. We want minimize the cost and also minimize the damage and the spoilage, okay. That's the objective in the warehouse, or sometimes we refer to a storage layout, okay, to store a bulky product, a large of or a high variation of products. That's a warehouse, okay, right. So okay, this is an example, the picture example for the warehouse. See, we have a lot of, this is a cube, okay. Alright, so usually in the warehouse, okay, we store a different item, different variation, different size of products, okay. Alright, so to manage this all these items, okay, warehouse use a system called automated storage and retrieval system, okay, ASRS, okay. So by using this system, okay, to manage, see, you can see there's a lot of variation of warehouse and a variation of items and so many items, okay, right? And by using this system, okay, is usually can improve the warehouse productivity, okay. All right. So besides they use the SRS system, and also that to manage or to make efficient warehouse, they use a dock location, okay. So I will show the next one is the ASRS, okay. Okay, so this is example of ASRS. I have to stop this. Okay, to make sure that I share my computer sound. This is example of SRS, how to manage the warehouse. Okay. Transport. Okay. Okay, so that's all for ASRS. Okay, the system to manage incoming. Okay, so for storage, and then also the system will manage for retrieval. Okay, retrieval the item means that is for outgoing. Okay, outgoing items or outgoing transport, right? Okay, so and then another important component in the warehouse layout is the relationship. Okay, means that the relationship between the receiving, okay, unloading area, and means that is incoming, and also the shipping or loading area for outgoing. Okay, to ship incoming and for outgoing area. Okay, to manage that area. Okay, right. So that's very important to design the facility. Okay, that depends to the supplies that you want to unload. Okay, so warehouse depends to what supplies that you want to unload, and then what they are unloaded. Okay, from what product and from what. Okay, either you want to unload from trucks, rail cars, or so on. Okay, depends to where, to which, from which. Okay, and where they want to unload it. Okay, where, right? Okay, so when you want to design the facility layout, okay, so it's depend to the type of you want to unload, okay, what from what, and then where is it you want to unload, okay, right? So this facility, okay, we refer to as a docks, okay, docks to unload and uh, unload, and then we want to pass to another area, right? Okay, so this is something for the docks, or the new system we call it as a cross docking. Okay, so cross docking, we try to avoid storage. Okay, so we receive the items, and automatically we distribute and we ship the item directly. Okay, so that is the purpose of cross docking. ASRS, okay, in the warehouse, so for you to keep the products. Okay, did someone do something to my slide or not? Okay, you try to highlight. Okay, all right. So there are a few systems in the warehouse. You have to differentiate. Okay, ASRS for storage means that there is a storage. But cross docking, okay, you want to manage the items, receiving the items, and automatically you want to ship the item. Okay, you distribute and ship the item. Okay, so that is where you will do at dock. Okay, or now the system we call it as a cross docking, right? In the cross docking, is because you need a very tight schedule when you want to receive the item, okay, and then you have to distribute the item to different places, okay, or to distribute to different shipping trucks, okay. So then you need another technology, okay, example as a barcode technology or RFID to identify what product is it, where they want to ship, okay, receive and then ship automatically. Okay, no storage, no because the storage, some company identify that the storage is no value added activity. Okay, you just store the item. Okay, so nothing happened to the item you produce, and then you just store that. Okay, but it, no value added, but you have to pay cost for that storage. You know? Okay, it costs to the company. So to avoid that storage, okay, so they apply the cross docking. This example of cross docking. Okay. So this is receiving the items, okay, and they will pass. They have this is what you call okay, high speed camera tunnel to identify the products. Okay, scan the products. Okay, and they do some labeling here. Okay, Okay, they receive a multiple item, okay, different from different company, receive from different company, multiple item, okay, and they transport to shipping area, okay. If you need to weighing, then they need weighing, and they scan the destination where they want to ship this item, and they divert all the items in the different shipping lane, okay. So now different item receive from different item. Now they pass it to the to ship, okay, automatically. Okay, so they don't have to store the item. Okay, so different. So from the one warehouse, then they automatically distribute to different punya dia punya retailer, right? Okay. Okay, so another system in the warehouse also, they have sometimes they use a random stocking. Okay, random stocking. Okay, they need a automatic identification system. Random stocking is a they keep or they store their items randomly. Okay, they don't have a system that one item they group the item and keep in the one space, one area. No, okay, they just put it in randomly. Okay, alright. So let me show you one video for you to understand what is the random stocking. It started by Amazon. Okay, random stocking. It's a randomly, see the box, the toys with the it's randomly stocking. Automatic identification system. Before they store, they have to scan and keep in the system. Okay, so that is a random stocking, right? Okay, and also in the warehouse, okay, sometimes in the warehouse they do some customizing activities. Okay, you can customize in the warehouse. Okay, laptop, they customize the final customization to in the warehouse area, some type of laptop. Okay, can assemble some components, or they can do some labeling in the warehouse. Okay, also that some computers companies, okay, they use the warehouse as a place to repair. Okay, let's say your computer fail, okay, and you return to your manufacturer. Okay, the replacement though, okay, the replacement to you sent from the warehouse, okay, as soon as possible. Okay, but your old machine, your old computer, okay, arrive at the warehouse. They do some repair at the warehouse, not at the factory, okay, or not at another store. Okay, right? So when you return, they do some they return back, they give you a new one. Okay, let's say if the warranty, you get a new one, so you get a new one. Okay, but the old one they repair and they give it to another person, maybe as a second hand or as a refurbished computer. Okay, right? So but they done this at the warehouse, right? So this type of customizing in a warehouse, okay, so it's enable when you use the low cost strategy and rapid response. Okay, you need to respond quickly. So this is the best way. Okay, customizing at the warehouse, so you don't have to go to the factory. Okay, all right. So can do a lot of things. Okay, a lot of company can do a lot in the warehouse, right? So this is what we call it as a value added activities. Okay, in the warehouse. Okay, usually warehouse use a place to distribute only, but now they add another activity to customize. Okay, and not all warehouse like to customize, only certain warehouse, but this is can be done at the warehouse, right? Okay, so that's warehouse layout. So another layout is the fixed position layout. Okay, so fixed position layout. Okay, products is in one place. Okay, so all the materials, workers, and equipment you have to come to the site of that products. Okay, right. So the problem is the warehouse. Okay, not problem lah. There is disadvantage. Okay, or the things that you have managers have to consider because fixed position layout, you have very limited space, okay, at the site. Okay, you have to do everything there. You have to bring everything to there. Okay, and you have to remember, usually it's used for projects. Okay, so you need a different items at different stage of project. Okay, right? So different materials. So you have to plan very properly when to bring this item, at what stage, and when is it. So and then you have to complete a previous stage to on time. So that when the materials for the next stage arrive, you have to complete the previous stage. Okay, right? It's difficult to plan, right? And the volume also is the need is quite dynamic. Okay, it's not constantly. Okay, maybe you need a still at different stages, so you need different volume. Okay, all right. So it's a quite complicating factors. You need a very proper plan. Okay. Um. Okay. So this is example of usually using a shipping company, shipbuilding company. Okay, fixed position. Project building housing project. Okay, all right. So nowadays they have another alternative strategy. Okay, which is they try to complete the product at the offsite. Okay, so usually it's on site, but they try uh, to complete certain component offsite. Okay, such as previously, okay, if the project, maybe door, windows, tiles, they can complete it offsite, okay, not on site. Okay, so they just bring it to the site and just to assemble that. Okay, but now, okay, you can see here, okay, but not yet in Malaysia. In Malaysia, we just build some components only on the offsite. Okay, all right. Okay, you can see here they build the house in the factory. Okay, so they build and then they bring this house, put in the truck or whatever, and bring it to the on site. Okay, bring to the site and they just put it there. Okay, so I think in the US, I'm not sure in which country, but not in Malaysia yet. Okay, they build the house in the factory offsite. Okay, not the on site. Also another company tried to divert the on-site. It's a shipping company, okay, but this fixed position layout for services, example in the operating room, okay, operation room, okay, patient in the operation table. All the personnel, all the doctors, all the equipment, all the medical supplies will come to the patients. Okay, but this one cannot be done offsite yet. Okay, right? Only for product services might be difficult to do it offsite. Okay, so this is example of fixed position layout. Okay. right? So the next one is the process-oriented layout. Okay. Okay, so in the process-oriented layout, okay, the company will group machines or equipments or skills. They will group together, okay, so that the workers have the flexible or capable to handle uh, uh, a variation of products or services, okay. But the problems in the process-oriented layout, because you will group, okay, machines together, and then you can produce the variation of design of products. So the scheduling is might be difficult, okay, and also you need the setup time may be quite high, because one process you can produce the variation of design, the variation of products, okay. So also that the how you want to handle the material for different different product, okay, variation for the products, and also you have maybe the cost for labor is quite very high, because this labor has to handle the flexible machines, okay. Means that they need really high skills, and you have to train these workers to handle the flexible machine. So the cost is, for labor, is a little bit higher compared to the next layout we will see, okay, right? Okay. Okay, so remember the process oriented layout is that you group the process, the similar process together, okay. Similar process is either if you have used machines, so all the machine you group it together, okay, and all this machine will process a different product, okay. So this is example of process oriented layout in hospital. So okay, so surgery department you put in one area, but different type of surgery, but surgery you put in the one department, okay. Alright, so this is CR triage room, okay, one area, emergency room, laboratories, okay, one area, okay. But lab, different type of tests they have to that, okay, to do, okay. But you still you put in the one area, one process. Okay, radiology, okay, you have MRI, CT scan, different type of scan, X-ray, okay, but still in one area, different type of equipment, but you put in the because it's considered as a similar process, okay, radiology. Okay, and radiology expert is in one area, okay. So ER beds, and the pharmacy area, and the billing area, okay. Now we will see different patients, okay. I will show you example two patients, okay, different different sequence of the process, okay. So patient A, okay, this is a route for patient A. Exit. Okay, so this is a route for patient A. Patient B, okay, erratic heart pacemaker. So need to go to different area, go to lab and billing and exit. Okay, right? So different patient A. So means that hospital cannot design the process or the department based on patient's requirement, because different patient need a different process, okay, different sequence to complete their process, okay. Alright, so then the products or the patient's product has to follow the process, okay, not process follow the products, okay. Alright, so okay, so the objective for process oriented layout, okay, is that you have to arrange the work center to minimize the cost of material handling, okay. You try to minimize the cost of material handling, okay. So when you want to arrange this work center and to minimize the cost material handling, okay, two things that two elements that you have to consider or you have to take into consideration, which is the number of loads, okay, either of people or loads, okay, moving between the centers, okay, number of loads moving, okay, and also the distance of loads or distance of people move between the center, okay. So when you want to arrange the work center, the object to minimize the cost. So you have to consider these two things. Okay, number of loads moving between centers and the distance loads move between centers. Okay, only this is most important. Okay. Oh, sorry. Okay, so I'll show you how to use. Usually, you have a system, but I'll show you how to calculate to design the process work center while you will try to reduce the material handling cost. Okay, so this is the calculation to minimize the cost. Okay, number of loads. Okay, the number of loads move between department. Remember two element, number of loads move, and we will times by cost to move a load between the department. Okay, cost to move between the cost or distance, depends lah the measurement. If your measurement is cost, then you cost the movement move to load between the department. Okay, or the distance to move between department. Okay, move to distance to move a load. Okay, number of loads, and then the cost or distance to move the loads. Okay, and we total everything, then we try to minimize this. Okay, so example, you try to read this. Okay, so this company would like to arrange 6 departments. Okay, so this 6 departments, so each department has their own process. Okay, all right. So, and also the objective to minimize the interdepartmental material handling cost as usual. Okay, to design the process layout to minimize the material handling cost. Okay, all right. So, dia punya area tu, each department same area. Okay. Okay, so the building, this is the space for building, 60 feet long times and 40 feet wide. Okay, so now we would like to arrange that 6 department in the factory, then that we can minimize the material handling cost. Okay, so this is the original punya. So before that, we have to construct a from to matrix. Okay, alright. So this is what we call a from to matrix. Means that doesn't matter, it's either from one assembly department 1 to department 2, or from department 2 or to department 1. Okay, I mean that we have to combine both loads. Okay, the loads from assembly department to painting department. Okay, and also the loads from painting department to assembly department. Okay, from and to, we combine both, two ways. Okay, all right. Okay, it's either one way or two ways, we have to combine. This is what we call a from to matrix. Okay, all right. Okay, so from assembly department to painting department, and from painting department to assembly departments, the loads is 50. Okay, we in this table we cannot differentiate. Is it from assembly to painting or from painting to assembly department? We don't know. Okay, this is a from to. Okay, we have to combine both. Okay, means that the interaction between these two departments is 50 loads. Okay, it's both way. Okay, so from assembly department to machine shop department is 100 loads. Okay, also two ways. Okay, receiving assembly to receiving, no loads. Okay, shipping assembly to shipping or shipping to assembly also 0. Okay, and assembly to testing, testing to assembly is 20 loads. Okay, so this is from to combine, from and to combine. Okay, right. So and the rest one. Okay, so next, first you have to construct a from to matrix. Okay, and then okay, this is initial punya design. Okay, let's say initially, okay, we just put area here. Okay, remember the space area is same. They assume that every department have the same space area. Okay, all right. Yeah, so this is original punya area. So we do some calculation. Okay. Okay, so this is the cost. 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 Okay. So this is a cost of move the loads from department to another department. Okay. So the cost to move the loads from assembly department to painting department. Okay. Cost to move the loads is $50. Okay. Cost. Right. So this one is the loads. Okay, the loads, number of items is 50. Okay, this one is cost to move per loads. Okay, okay, cost to move per loads. Okay, so to move from assembly department to painting department, the cost is 50. Okay, to move from assembly department is one department. Okay, assembly department to machine shop department, cost to move is 100. Okay. So cost to move between painting department to machine shop department is 30, and this is the rest cost. Okay, from receiving department to painting department, cost to move is 50. From assembly department to testing department is 20. Okay, cost to move per item or per loads. Okay, but number of loads in different table. This is cost to move. Okay. Cost to move between painting department between painting department and shipping department is 10. Okay. From receiving department to shipping department is 50. Right. So this is cost. Okay. So remember we have loads two elements, number of loads and cost to move the loads. Okay. We already have two both. Okay. Alright. So based on this layout, okay, this layout and the cost, okay, we will calculate the total cost to move the loads, okay, right, using this formula, okay, cost. Okay, so cost to move between department 1 and department 2, department assembly and painting is 50, okay, so 50 here, okay, plus 200, okay, from department 1 to department 3. Why is it 200? It's only 100. This is 100 from one department to another department. Remember this layout, okay? This layout, okay? This from assembly department to machine shop department 1, 2, 3. You have to go through another department. So 100 to to move that load, so okay, and then another 100 times 2, okay, times 2, 200. Okay, 1 to 6, 1 to 6, then you don't have to 1 to 6. Okay. Also, you have to times 2 because from assembly department, you have to go to another department first, and then you can go to the testing department. Okay. Right, so times 2. Okay, 2 to 3, 2 to 3, okay, side by side. Okay, 30. 50, 2 to 4, 2 to 4 also side by side. Here. Okay, 2 to 5. You don't have to times by 2. Okay, 3 and 4. 3 and 4. See, 3 and 4 here is 20, but you need to go to another department. Okay, so 2 times 20, 40, and 3 to 6, 100. Okay, 4 to 5, 50. Okay, so the total cost is 570. Okay, this is the total cost. Total material handling cost for this layout. Okay, total. Okay, can you think that we can reduce this material handling cost? Can or cannot? Okay, of course we can, because we can see here this is the most the cost is quite high, 100, okay, to 100, but they have to move 2 times. Okay, so this is what we want to reduce. Okay, so reduce this material handling cost. Okay, so assembly one, department assembly and machine shop should put side by side. Okay, because the cost is quite high for the handling cost between these two departments. Okay, that's why we have to move assembly to near to the machine shop. Okay, so now we like to improve the layout. Okay, so we revise assembly. Okay, department assembly we put here near to the shop. Okay, right. So let's say this is okay. For this layout, it's just like you do try and error. Okay, but you have to look into in depth. Okay, to see the most cost or the higher cost or the highest load or the highest distance should be near near to each other department. Okay, right. So if we move assembly here and painting here, okay, so we recalculate the total cost. Okay, now the total cost after we move assembly to near to the machine shop. Okay, now total material handling cost is 480. Okay, see, you can reduce. We move one department, we rearrange the department, okay, to the near the other one, so we can reduce the material handling cost. This is the objective for process layout. We want to make sure that process that higher cost or higher distance is stay side by side near to each other. Okay. Alright, so I have another video. Okay. So this is a new layout. Okay. So I prepare another video to show you how to do it manually. But I will not show today, but I will post it in the Putra Blast how to calculate manually. Okay. So later I will when I upload this video, okay, our class today the video, I will upload together with the exercise video, how to do the exercise video together with this video, right? Okay, so you can watch how to do it manually to calculate, to do it by yourself, right? Okay. Okay, so usually we want to design the process layout. This is the computer software that available lah. Okay, we have a computer software. Okay, so computer software that you can plan the flow path. Okay, so we rearrange the department. You can calculate the material handling distance, cost, and then the system will generate to you the efficient layout. Okay, alright. So also that there is another technology, a new technology that you can visualize. Okay, I have three-dimensional visualization software that you can see the possible layout. You can rearrange, you can see the movement. I can do some simulation there. Okay, so that now you can before you launch, then you can see how to handle the material, the safety issues. Okay, like the actual one. Okay, you have 3D punya. You can visualize this before you implement that. Okay. So because when you want to design this process layout, this layout is really costly. Okay, it's not easy to change between departments. Okay, especially if you have a machine, a high bulky machine, bulky technology, so it's not easy to move to one place to another place. Okay, so that now we have a software to visualize before you actually implement that. Okay. Right, so the next layout is work cells layout. Okay. Okay. Okay, so this work cell layout, okay, company reorganize, okay, reorganize the people or machines into a group or to focus, okay. So usually work cells it to focus on single products or a products group, okay, right. So you group the technology, okay, to similar products, okay, or to the similar characteristic of the products, okay, right. So okay, so this works, okay, or we call it as cellular works arrangement or cellular work layout, okay. Usually we use that when the volume volume needs a special arrangement, okay, and also need a special type of machine and equipment, okay, right. So we arrange that based on that very need for the specialization, okay, right. So a lot of this advantage of work cells, okay, you arrange it based on work cells, okay, based on that group of technology, okay. Okay, so this is for reduce work in process, less floor space required, reduce raw material and finished good, reduce the direct labor cost, okay. This is all advantage of work cells, okay, right. So when you want to arrange cellular work layout, okay, first you have to identify the families of product, the similar products, okay, that you want to produce, okay, because the cell design, the requirement is for you to produce a similar products, okay, right. And then usually you need a high level of training and the flexibility of the employees, okay. You need to train because the machine also usually is very specialized, okay, and also you have to empower the employees to make a certain decision, okay, and that cell, okay, usually cell is being self-contained and also they have their own equipment and company have to assign a special resources, their own resources, okay, and also that each station or each work cells, okay, they need to do a testing or they need to embed the Pukayuk in each cell, okay. Test at that area. After you complete, then you have to do some testing to make sure the quality of the product is up to the extent, okay. Right. So this is a requirement before you move to the work cells, okay. Okay, so this is the work cells, okay. This is also the work cell juga, okay. Right. So current worker, okay, work is small area, so you take this material and they do their own work, okay. So that when you improve, okay, you improve the work cells, okay, you cross train workers that these workers need to workers able to assist each other. Okay, this one they do their own job. Okay, they cannot. If these workers, okay, see, if these workers, okay, this one have a problem, okay, cannot attend, cannot is absence here. Okay, so this one cannot replace this one. Okay, so when you design like this, okay, so you have to cross train and both workers able to handle both machines. Okay, so they can help each other. Okay, so this is a more efficient layout. Okay. Okay, so how to clear this? Not erasing. Okay, so this is the current layout. Okay, straight lines. Okay, so and then there's a possibility that the task is not evenly divided. Okay, right? So maybe some workers have to handle more machines compared to the others. Okay, and you need a 4 workers. Okay, so if you improve like this, you put in the U shape. Okay, so the workers have better access to all the machines. Okay, and instead of you need 4, you need only 3. Okay, the access is small. Okay, and also that you can cross train. Okay, in the work cell, you have to cross train workers to able to use all the machines to handle all the process. Okay, that's most important in the work cells. Okay, so U-shape line, they can reduce the employee movement. You don't have to move to from another machine to another machine, less movement. Okay, and also that space requirement, okay, is reduced. It can communicate more, okay, between employees, and also it can facilitate the inspection process. Okay, so testing process is better. Okay, right? So they can this is better layout compared to the straight line, right? Okay, so we have to improve the work cells. Okay, uh, in the work cells, we need to, the most important is how we want to staff and balance the work cells, okay, to make sure that they produce, all the workers produce at the same time. Okay, so the okay, this to determine this, okay, it's involve 2 steps. Okay, we call it is a 2-step. Okay, first you have to determine the takt time. Okay, takt time, which is the pace of production units necessary, time per unit to meet the customer orders. Okay, the time for each workers um, uh, to complete the process for each unit. Okay, takt time. So you have to determine that takt time. Okay, the pace. So every workers have to do this to work at the same, to complete at the same time. Okay, alright. So how to calculate the takt time? Okay, total work time available divided by units required. Okay, that is the first step. And then next, you can determine the number of operators required. Okay, workers required, how many workers they required, and each workers need to work at what time. Okay, right? Total operation time required divide by takt time. Okay, so example. Okay, so Honda expects, okay, this company, okay, okay, so this company produce mirrors. Okay, so the customer expect 600 mirrors delivered daily. Okay, and this company, okay, and the itself producing the mirror is scheduled for 8 hours per day. So they will work 8 hours per day, and they want to produce at least 600 mirrors, okay, daily. Okay, now we like to determine the takt time on the number of workers. Okay, so this is the operation to produce the mirrors. Okay, so assemble department, 40 seconds. This is in seconds. Okay, to produce assemble 40 seconds. Paint about 35 seconds. Testing times is 10 seconds. Label label is 20. Okay, 20 seconds. No. 0, the numbering is I mean is quite Okay, 10, 20, 30, 40, 50 for assemble. Okay, so labor is 20 and pack for shipment is 15 seconds. Okay, so this is task required to complete the mirrors. Okay, so 600, this is a requirement, 600 mirrors per day required. Hey. Okay, so mirror production schedules for 8 hours per day. And you know the total operation time is 140 seconds. Where do we get this 140 seconds? We have to total all here. 50 plus 45 plus 10 plus 20 plus 15. Okay. So total is 150 seconds. Okay. So total here, then we get 150 seconds. Okay. So formula for takt time. Okay, total time workers available. Remember, production schedule is 8 hours per day, 8 hours time by, because this is this one. Okay, every task is given in seconds, so we have to convert it in the seconds. Okay, if in minutes, we have to use in minutes. Okay, 8 hours time 60 minutes. Okay, divide by 600 units. Okay. So 0.8 minutes means that 48 seconds. Okay, so we have to convert in seconds. Okay, right, 48 seconds start time. Okay, and worker, how many number of workers required? Okay, total operation time required 140. Divide by start time 48 seconds. Get a 2.9 means that this company needs 3 workers. And each workers need to complete the process in 48 seconds per unit. Okay, 3 workers, and the pace for the works is 48 seconds per unit to complete, so that they can complete 600 mirrors per day required. Okay, so the process 1 unit, after 48 seconds they have to start a they start the next unit. Okay, complete in 48 seconds, start a new unit after that 48 seconds, and you have to pass to another department. Okay, so every 48 seconds they need to start a new the next unit. Okay, right, so if they cannot complete in the 48 seconds, okay, let's say they only complete after 55 seconds, means that it's difficult for them to fulfill the daily requirement here, 600. Okay, so it's difficult to complete here. Okay, that's why the takt time, the pace that we will give to our employees. Okay, every 40 seconds they should start a new unit. Okay, 48 seconds pass, 48 seconds pass, 48 seconds pass. Okay, right? Okay, so the work balance chart ni to help for work cells. Okay, plan that to also staffing and balance too. You need a work balance chart. Okay, which one is a work balance chart? This one. Okay, this is a work balance chart. Okay, right. Okay, so this chart by preparing this chart, okay, also can help to identify the bottleneck of operation. Okay, we can identify which process that can give a bottleneck to operations. Okay, so that you can reduce that. The bottleneck is not good, and we reduce the efficiency of effectiveness of the process. Okay, if you identify the bottleneck, it is because of the employees. So maybe you can cross-train employees so that another employees can help the workers that cause to the bottlenecks. Bottleneck happens when the if the takt time is 48, so this labor complete only after 55 seconds. So they will start later and later and later, so the products will keep will then this label will have a bottleneck. Okay, So it's easy if the bottleneck caused by the employee. So you just cross-train to other employees to help this labor. But if the machines cause the bottleneck, so maybe another approach that maybe you have to change a new machines or buy a new change to a more efficient machine or buy a second one to help to reduce the bottlenecks. Okay, so bottlenecks get a lot of problems with the bottleneck. I think this is already discussed in the previous chapter. Okay, right? So that's why you the company in the work cells layouts, they need to have this work balance chart, okay, to reduce the bottlenecks. Okay, and also besides the work cells, okay, sometimes they refer to focus focus work center and also focus factory. Okay, focus work center means that it's a work center. They is a work center, a sub center in the factory, okay, to produce some products. Okay, it's in the one process, but they focus on certain center. Example, Toyota, okay, they have a focus work center. This focus only to produce they only to produce bumpers only, okay, in Toyota, okay. So but still in the same factory, but that work center to focus only bumpers, okay, and or sometimes they focus only to produce dashboard, okay, but still in the same factory, okay. So they produce a similar product, and this product have a stable demand their own, okay, right? So this is what we call a focus work center. But if this work cell or this focus work cell is in different facility, in different places, not in the same factory, okay, this is called a focus factory. Okay, example, if you build a separate plants that produce only seat belts, okay, so the dashboard, the example of dashboard too, they produce in the same factory, but they have their own work center, okay, only to focus dashboard. Okay, the workers focus on to produce dashboard only, or to produce bumpers only, okay, but in the same factory. But let's say they build a new plant just to build or produce seat belts or exhaust, okay, in different factory. That is we call a focus factory, okay. Alright, so sometimes there is a work cell as cellular workout, okay, focus as in similar, okay. But if it is the same factory, we call it as a focus work center, okay. But if in different facility, in different the new plant, okay, to focus certain, so that because we call it as a focus factory, okay. Okay, so the next one, okay, is a repetitive and product layout. Okay, this is the last layout. Okay, repetitive. Okay, so repetitive, usually repetitive. Okay, I think this one is already in the process. Good, explained in the process. The repetitive process usually use a product-oriented layout. Okay, so we organize the process based on the products to produce that product. Okay. And the strategy for this product-oriented layout to produce high volume and also low variation of the products. Okay, right. Okay, so this is an assumption for product-oriented layout. Okay, volume is indicated for high equipment utilization. Okay, so we will buy a high equipment. We will fully utilize the equipment. Okay, product demand is stable enough. Okay, for that you to buy the specialized equipment. Okay, a product is standardized. Okay, all the product is standardized and approaching a phase of life cycle that justify investment. Okay. So if the life cycle comes to the matured or declining, then it's not worth it to invest in the specialized equipment. Okay. All right, and also that supplies of raw materials and components are adequate, okay, and uniform quality, because you will produce a same standard for the product. Okay. Okay, so in the product oriented layout, usually for fabrication line, you have a fabrication lines or assembly lines. Okay, two type of product oriented. Okay, fabrication lines to build the components. Okay. Alright, and assembly lines, we will put the fabricated parts together, right? So the paste fabrication usually is based on the machine paste. In the assembly line, paste usually paste by work task, okay? Right, so in the assembly, in the fabrication line, okay, we need to balance the production, we need mechanical engineer, because in machine paste, so to balance the productions, to balance the between process, usually we need to change based on mechanical or engineering. Okay, you need to adjust the machine. Okay, to make sure that the balance between the process, process 1, 2, 3, okay, is same, right? But in assembly lines, because the pace is by work task, okay, so the balance to balance that by how you want to move from one task to another task. Okay, so in assembly line. Okay, alright. So to make sure that the both, okay, fabrication line, the assembly line, we have to balance that to make sure that each station work at the same pace. Okay, if machine, then all the process will work at the same pace. So you have to adjust based on that. Okay, in assembly line, okay, you have to balance moving the task from one to one. Okay. One task to another task. So to complete each task ni, you have to balance that. Okay. Okay, so this is advantages for and disadvantages for product oriented layout. Okay, you can read yourself. Okay. Right. So this example. Okay, the process in assembly line in the McDonald's. Okay. Right, so from buns, starting from order, receive order, and then take a bun, prepare bun, okay, and until the end of here, okay, at the time required to make sure that all work at the same pace, okay, right? Okay, so now I will show you how to fabricate it, because it's a machine, so you have to adjust the machine. So how to balance the assembly line, okay? We call it as a assembly line balancing, okay? So the objective for line balancing, okay, so to minimize the imbalance, okay? So to minimize the imbalance between the personnel or machines while meeting the required output. Okay. Okay, so in the assembly line balancing, okay, we will identify the precedence relationship, okay, the previous activity, the activity before we can start a new process. What is previous activity? Okay, I want to start process B, so I have to complete process A. Okay, so A is the precedence activity for B. Okay, so this is the precedence relationship. Okay, alright. So then we can determine, okay, based on this precedence relationship, we can determine the cycle time for each workstation. Okay, we also can identify or calculate the number of workstation. Okay, minimum number of workstation. How many workstation to balance the movement. Okay, so how many workstation that we need. Okay. Alright, so and we can balance the line by assign the task to workstation. Okay, this is what we'll do in the assembly line balancing. Okay, we can determine the cycle time. Okay, to complete each in each workstation to complete task for each unit. Okay, there is a cycle time, and then we can identify the number of workstation. Okay, and then we can assign the task for each workstation. Okay. Okay, so this is example. Okay, they want to assemble electrostatic wing component. Okay, so need they have 10 activity, 2, 4, 6, it's 9 activities to complete this. Okay, and the total assembly time for each unit is 65 minutes. Okay, so in this area, okay, task must follow task listed below. This is the precedence, predecessor. We call it predecessor. Okay, we can start B only after we complete A. Okay, and also E can start only after we complete A. Okay, we can start C and D after we complete B. Okay, so this is a predecessor, or all of this we call it as a precedence relationship. Okay, right? Start G after we complete F. Okay, right? So we can draw the precedence relationship based on this list. Okay. Right. So I want to show you how to draw the precedence activity. First, because A here no predecessor activity, so we can start A directly. Okay. So after B can start after A complete. Okay. Alright. So before that, okay, A 10 minutes. Okay, assembly time we put 10 minutes here. Okay, and then we can start B after we complete A. Okay, 11 minutes, right? Okay, so we can complete, after we complete B, we can start C and D. So see B, after B, C and D. Okay, so 5 minutes for C and 4 minutes for D. So E start after A, okay, 11 minutes. F start only after C and D complete. Okay, F. The next is G. Okay, complete after F, 7 minutes. Okay, H start after E. Okay, H after E. Okay, and I after G and H. Okay, 3 minutes. Okay, so this is what we call a precedence diagram. Okay, this is precedence to show the predecessor relationship. Okay, next we would like to calculate remember I said that we can calculate for line balancing, calculate the cycle time, okay, the maximum time allowed at each workstation. Okay. Right, so this is the formula, cycle time, production time available per day, divides by units required per day. And also we can identify the minimum number of workstation. That is the task only. Okay. So now we want to identify the workstation. Okay. The total task duration divide by the cycle time. Okay. The total time divide by cycle time. This is the formula. Okay. We go back to the case wing component example. Okay. So Boeing, that is the process. So now Boeing determines that there are 480 productive minutes of work available per day. Okay, 480 productive minutes of work available per day. Furthermore, more than production schedule requires that 40 units of the wing component be completed as output from the assembly line each day. Okay. Now they want to group the task into workstation. Okay, ada 480 works available, 480 minutes work available per day, and it requires to produce 40 units. Okay, right. So cycle time, production time available divide by units required. So production time available is 480 minutes. Okay, it's available time. And units required per day is 440 units. Okay, right? So 440 divided by 40. You got cycle time for each workstation. You need to complete 12 minutes per unit. Okay. Every units, 12 minutes, then you have to pass to the new workstation, to the other workstation. Okay. You have to start a new unit. Complete after 12 minutes, you should complete it to avoid the bottleneck. So, okay. So, is it line? Is it clear or not? Okay, so the next we identify the minimum number of workstation. Okay, so total time for task divide by cycle time. Where do we get this total time for task? Okay, remember this table? Okay, so this the total time 65. Okay, so this is the total time. Okay, so 65 cycle time 12 minutes. Okay. So 65 divided by 12, we get 5.42, okay? Or 6 station. You cannot round based on normal punya ni. Even though 5.2, we will round up to 6 station, okay? More than 5, then you have to extra one, okay? 6, okay? More than 5. 5.9, 6 workstation. 5.1, also 6 station. Okay, right. So now need each station. We need 6 station, and each workstation need to complete 1 unit. Need 12 minutes to complete 1 unit. Okay. Now we will assign. Okay, to assign the task to workstation, there are about 5 methods. Okay, right. But in this example, we will use only the rules here is most following task. Okay, the rules here, the name is most following task. Okay, so from the available task, choose the task with the largest number of the following tasks. That is the rules. Okay, right. So to assign that. Okay, so now this is calculate the cycle time 12 minutes, workstation 6. This is the list of tasks, and this is our precedence diagram. So now we will assign 12 minutes. Remember, maximum 12 minutes for each workstation. Okay, so the first we will start with A. So A, we have 10 minutes. A 10 minutes, B 11 minutes, and E the next following. Okay. B, after A is B and E. We cannot consider C and D because B is still not assigned yet. Okay, so we have to go step by step. Okay, so first start by A, 10 minutes. So we need 12 minutes, but 10 minutes. If we combine A and B, it's already 21 minutes. So we cannot combine. So we can only assign A, process A in one workstation. Okay, right? So the next following task is B and E. So B 11 and E also 11. Okay. So 11 and 11 also cannot combine. So B one workstation. Okay. So B one workstation and E also one workstation. Okay. So the next following task is C and D. Okay. C and D and H. Okay. C and D. 5 plus 4 is 9. Okay, 9. This is 11. 5 plus 4, 9. 9 plus 3 is 9 plus 3 is 12. Okay, so 12 means that you can combine this. Okay, right? Combine. So the next workstation 12. Maximum is 12. Okay, cannot exceed more than 12. Okay, so H and G and I. Okay, the next following H, G, I. H11 cannot combine. Okay, so H the next workstation and G I combine in the workstation. See, we assign 6 workstation. You should get 6 workstation, and maximum cycle time is 12 minutes. Okay, for each workstation. Right? Okay, so the next we can calculate the effectiveness of line. We want to identify the effectiveness, okay, the efficiency of the line balancing. Okay, To calculate the efficiency, task time, total task time divide by actual number of workstation times by larger cycle times. Okay. And also we can identify the idle time for the line. Okay. The formula for idle time is that actual number of workstation times by larger cycle time. Okay. And minus task time. Okay. We go to the case here. Okay. This is we reassign. Okay. So first workstation 11 minutes. Second workstation 11 minutes. Okay. Third workstation 11 minutes. Okay. Fourth workstation is 12 minutes. Fifth 11 minutes. And the last workstation 10 minutes. Okay, 7 plus. Okay, so calculate the efficiency, task time, total task time divided by actual number of workstation times by the largest cycle time. Okay, task time, task time is 65. Remember last time, like the previous one. Actual number workstation, we have 6 workstation. Okay, the largest cycle time you can see 11, 11, 11, 12, 11 and 10. So the largest one is 12. So we use 12. Okay, 65 task time divided by 6 workstation times by 12. Okay, so equals to 90.3%. So the efficiency of this workstation is about 90.3%. Okay, so at the time, okay, actual number of workstation times by the largest time minus total task time. Okay, so 6 times by 12 minus 65 minutes. Okay, so the other time is 7 minutes. Okay, so in the whole process, the idle time is only 7 minutes. So okay lah, with 90.3% efficiency. So it's quite okay to design this kind of workstation. Okay, right? Okay, so that's all for this chapter. Okay, do you have any question? Sorry. If you want to interrupt, you should start you on your mic. So if you write here, I cannot know. Okay, what is it, Haikal Alif? Haikal, why you want to interrupt me? You have any question? Start time, okay. 60 minutes. 60 minutes is given in the that time. Oh, 60 minutes. So, alright. Let me share this one. This 60 minutes ni. 8 hours time by 60 minutes. Is it this one? Okay, so 1 hour, how many minutes? One hour, how many minutes, Haikal? 60 minutes. There where you get 60 minutes. Okay. You have to from 8 hours. Yes. 8 hours by hours because the time let me see. Okay. Because the schedule or the production per day is given to you by hours. Okay. And to complete one unit is in seconds. Okay. Sometimes maybe you can also divide by 8 hours time by 60 minutes time by seconds. Convert directly to the seconds. Okay, it's more easier. Okay, but if the production time given to you in minutes, so you don't have to convert to minutes. Let's say they give you 480 minutes, so you don't have to convert to minutes. Amira, yes, I will, like I said previously, okay, there's another different video I already prepared to you. One calculation, one example how you to complete to do it manually. Okay, I will do it from the start, from the scratch, to do it manually. Okay, after you watch that video, I will give you another question. Okay, for you to do it. Okay, Haikal, understand tak? Why is it 60 minutes? Someone please copy the attendance. Where's the attendance? Let me copy. Okay. Thank you. What slide? Oh, stop share. You want to see which slide? Okay, anything that you want to ask? All clear. Right. So next Monday is a public holiday. Do you have a class every day? Every day you have class. Thursday no class. Alright, it's okay. So Monday we don't have class. So this 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 is week. This is week what? Week 8, isn't it? Week 8 we have another. Okay lah. So we don't need any. I will not give you any recorded any pre-recorded video. Okay. Okay, right. Okay, so together with this video, I will upload the same example how to do the exercise lah. Okay, manually. I will do it manually, do manual calculation, give you the question, start from the scratch, okay, how to draw the diagram, how to calculate that for process layout manually, okay, how to calculate start time. I will record how I do the calculation and you watch that. After that, I will give you the exercise question. Test 2 next week? Cannot. You cannot do test 2 next week. I have to give you the question, exercise question for chapter for before the test 2. I mean for previous chapter. Because we have calculation in test 2. Chapter 8. Chapter 7. Okay, for crossover chart. Okay. And then for this chapter, okay, you complete that tutorial, then we can do the test. Okay, we just complete the chapter for test 2. You have to do some revision first. I have to test you. We have a 2 type of assessment, which is continuously. Okay, I will assess you continuously, and one is the our formal assessment lah, test 1, test 2. Okay. So you want to know date for test 2? When you want to do? Not next week. Okay, so next week cannot. Next week is week 9, week 10. Maybe end of week 10 or week 11 lah. Week 11. Week 11 lah, week 11. Okay, weekend week 11. You have class every day, isn't it? Or you want to do it on Thursday? Okay, now in this room, I have about 50 participants, but only 41 fill in the attendance today. Okay, so please fill in now, because after I stop this meeting, I will stop to receive. I will stop that form also. Okay, so you cannot fill in the attendance anymore. Weekend can. Yes, I will do it on weekend. You cannot go anywhere, kan? Weekend. You don't have any other activity. You cannot go to shopping complex. You cannot do anything. Instead of you just go and sit in your room, it's better you do the exercise or answer the exam. Right? Okay, only 42. So please, after I stop this meeting, I will stop the attendance. So you are considered not attend class today. Okay. No more question? Okay, so I'll see you next week on Friday. Bye-bye. Okay, bye. You all take care.